You guys ready? Okay. So let's go ahead and open HEC-HMS. So I guess let me backtrack a little bit. What we're gonna do right now is use the GIS functions in HEC-HMS that's gonna automatically delineate watersheds. Um, and I think this is a good workaround for you guys for an ORDDU instead of like manually doing that. Um, as an alternative to GIS. So hopefully this is helpful. So we'll just start off by making a new HMS file. So we go to File. Oh, no, sorry, not open. New file, new, and we can save. Name it delineation practice. And as a description, we can say AGA training practice. And then browse to a folder. If you already, I need to make one. So new folder, I'll name it hands-on delineation practice. And then I'll select it and I'll set my units to US customary and then I'll press create. And so now, like yesterday we had now it populates the project file folder here, but it's empty because we haven't added those components. Um, for this exercise, we're gonna start off by importing our terrain. So we go to compute components, terrain data manager, new. Here you can name your terrain, existing LiDAR, because sometimes maybe you're analyzing proposed condition, both existing and proposed, so name it existing. You can press next. And then here is where you go to the folder wherever you saved your LiDAR and you bring it in. So let me move mine. So now I'm gonna browse to my LiDAR and I'm going to select the one that has the TIF file type extension. So select it. I'm going to change my units to feet because the elevation units in my LiDAR are in feet. And then I'll click finish. And so now we see that on the left here, populated terrain data here.
Okay, so you said TIF, you got AUX and OVR.
Yes, so the one that says TIF.
They both say TIF.
So you go to here and then details. And you see in the type column,
Mm-hmm.
the one that says TIF.
Oh, I got you. I was just looking at the file name.
Mhm.
Thank you. Click finish.
And then make sure it's in feet.
Gotcha.
And finish. Yes. And so then you'll see that it populated on the left, and then you can go ahead and close the terrain window. So now that we have our LiDAR, we can create our basin model manager. So we go up to components, basin model manager, new, and we can call this let's call it our your um call it because it is the Brushy Creek area, but it isn't the entire Brushy Creek area. Keep that in mind.
Too huge.
Yeah, it'd be too huge. So we'll do that. And so now you see that it populated here. We still have to, those subbasins still aren't added. But remember, this is where they're saved once you start developing them. One thing that we do have to do is assign the terrain that we created to that basin model. So if we click on the Brushy Creek basin model here and come down to the settings, we can change the terrain data to existing LiDAR, which is the one that we just created. So that's telling HEC-HMS to use that terrain information for the analysis of that basin model.
So that means if you have multiple LiDAR data set, then you'll be able to select from here to attach to your basin.
And then from here, we need to set our projection system, our projection coordinates. So if we go to GIS, coordinate system,
Hold on for a second. Are we recording?
yes.
Thank you.
Let me make sure. I think we
That's the red.
Oh, yeah. Okay, yes. And so here, we're gonna go to browse. And we're gonna go to the projection, which should be the second file that I sent that's named 102739. And do you guys know where to find those projections? So if you go to I forget the site, but here. So this website, spatialreference.org, you can download your projections from here. So you just have to know what projection you should be using. But because you guys are in Williamson County, it's usually predefined. And
Texas State Plane.
mhm,
Is this central or south central?
Central.
Central.
Yeah. So Houston, we're South Central. You guys should be Central.
Yeah.
So if you go here to Esri, these are all the coordinate systems you can download. But if you know what you're looking for, you can type in the number. So you guys are 4203, which would be this one, NAD 1983 State Plane, Texas Central, feet. You would just click here and you would download the projection here. And so this is where I downloaded that projection coordinate system. And so now, when I go back to HEC-HMS and I'm going to set the projection, I can just click on the projection I downloaded, select it, and you'll see that it populates here, the coordinate system name and everything that it needs. Does that make sense?
Also, another way to do it is if you have in your project, if you already have, let's say, shapefiles that are, associated with this project, then because for the structure of shapefile, there's always a .prj file that's part of the shapefile package. And so if somebody's already developed anything, you have that shapefile as part of that PRJ. That's another quick way to do it. So you don't have to go and do the downloading. It's already there. We can just borrow it. That would work. I remember GIS had, when you get a shapefile, there's just usually a total of 4 files. 5 and some could be more, but minimum
I think I remember PRJ.
It's one of, yes,
Okay, that's what I mean.
yeah.
So then last question, so when you have the TIFF file, GIF file,
Mhm.
is that something you can visually open up and look at? Or is it one of those like binary file that you really can't see anything in it? Or is it a bunch of X, Y, and Z's? Is that what it is?
The short, even though it's called TIFF, so you would think of it as an imagery file, right?
Mm,
But it is actually, it's called a GeoTIFF. So it's a geo-referenced TIFF file. So I don't think you can just click on it and then open up like a regular imagery. I don't think so. The proper way will be, we'll have to um bring it in uh a GIS environment or any software that can handle uh spatial files.
Okay,
Yeah, I can look it up to see if there's any quick viewer that you can, let me check, you guys can come back.
it's okay. I was wanting to know that,
Mhm.
about the nature of a file that we get.
Yeah.
And so now that we loaded our projection, our coordinate system, we can press set. And now if you come back to GIS and coordinate system, you'll see that it's defined and it saves it here. And so now what we want to do, so whenever HEC-HMS delineates these basins, you can predefine the program settings so that when it makes a basin, it already tells it what transformation method to use, what loss method to use. So if we go here to tools, program settings, defaults, we can change here the loss method that we want it to use. So we're going to stick to SES method. And then we can just select the transformation method, which we're going to stick to a CS unit hydrograph. Our base flow, remember we kept it as none. Routing for now, we're going to keep it as none because that's not what our goal is. For precipitation, we're going to use frequency storm, which is the rainfall depth data that we looked at yesterday. Temperature, evapotranspiration, and SNOMA will keep us none because the major factor is infiltration. So this should look like this. And then we press OK. And so now what that's going to do is that whenever it delineates the basin, it's going to assign those settings so that you don't have to go in one by one and assign that. And so now we assigned the terrain data, right? So we assigned the terrain data to the basin model. And it should have loaded, but sometimes you have to click around a little bit for it to react. But in the step, whenever I assigned the terrain data to the basin model, if I would have clicked in and out of here, it would have loaded and we would have seen it pop up. But basically this is a section in like the Brushy Creek area that we were able to obtain. And it's just a very, very small section of LiDAR because the bigger the LiDAR, the longer it takes for it to process. So for our purpose, we trimmed it down. Oh, it's
Or maybe it's still working on it. I don't know.
click into existing LiDAR and then click back into Brushy Creek.
So
Sometimes it's a little funny.
Can you also show me your program settings one more time?
Mhm.
For
Yes.
default,
is it coming out?
Now,
the number of cores,
So let's see.
defaults. How come I don't see that? Number of cores, hydrologic.
Yeah, you need to.
It might be the version because you're using 4.13.
Yeah.
I'm using 4.12.
Hydrologic.
Might be that.
So they changed it a little bit,
Yeah.
but does it show up? The terrain?
Is it showing up yet?
Okay, now what I'm supposed to do to load it again?
Click into LiDAR and then click back into Brushy Creek. And double click into Brushy Creek.
Okay,
Oh, so you missed a step.
yes.
So whenever we import our LiDAR, it pops up here, right?
Yeah.
And then we created our basin model.
Uh-huh.
And in the basin model settings here, where it says terrain data, you have to assign it.
Attach it to your base.
Gotcha. Okay, so now go to existing LiDAR. Okay, there.
It, like refreshes it because it doesn't automatically pop up. So we're all caught up. Okay. So now we can actually start processing the LiDAR to start developing that watershed.
This is actually a good data set. Because you see that we have a roadway over there, right? And so there's a roadway crossing right in the middle. Yep. So we can indeed set our analysis point or our alpha at that location right here.
Yeah.
Yeah, so that means that everything water will be going towards that location.
Just to kind of reference the colors, because I don't, if you guys haven't seen it, but the white is like higher elevations, so like this gray white. And as it moves to red, orange, yellow, green, and this very light green, these are like your lowest points. So from this map, you can tell that if this area is like that white gray, your water's coming down this way, like this, like that. So it's a little easier to visualize than contours. But that's what the colors mean. Yeah. And so now that we loaded everything, we have our settings, we can start processing. So if we go to GIS, we want to go to Preprocess Sinks. And this could take a while. Depending on how big your LiDAR is, it'll take longer.
And so the reason for this step, sometimes I can see, but it's a good thing to do because, so as the name is telling us, so we're filling the sinks in this area, right? So the purpose for that is if there's any sinks area, that means the water will get there, and then the water will be able to continue down. If we don't fill the sink, then later on, when we carry out the entire process, there will likely to have some discontinuity in your stream network. So this step is essential for us to first, once we run through it, all the stream network will have positive connectivity, and then the water will be able to get from, when they're up the location, any location in your basin, and then if there's a connectivity to the outfall, the water will be ensured to travel to that spot. So that's the purpose of filling the sink.
So when it fills the sink, what is it filling it to? What elevation? Is it the most adjacent
It will,
point?
yeah, it will just, let's say there's a hole. Right?
Yes.
So we bring out to the lowest point, so where the water can find a way to continue down. Yeah.
Okay.
Okay. So now that we have our sinks, we can come back to our GIS section here, drop down menu, and we can say preprocess drainage. So now mine finished loading. Did your guys finish loading?
Yeah.
How does it look like this now? Okay.
Oh. Yeah.
Okay. So now if you zoom in, it's a little grainy, but all those lines that you see are different flow paths that it identified. So think of them as like streams, where your water
Stream network, yeah,
stream network.
yeah.
Um, and so as you're adding these layers, you can look at them individually. So if you go to view, map layers, here you can see all the layers that have been created through this processing. And you can turn them off and on depending on what you want to look at. But we can continue. After processing the drainage, we are going to ask it to identify streams. And what this pop-up here is asking me now, it's asking me to say, it wants me to say, consider something a stream if, let's say, 10 square miles is draining to it. So I kind of give it that gauge so that it doesn't consider a small stream flow path or stream, because I care about the big one, right? The big one that we saw going towards the road. So for this part, I feel like you kind of have to iterate it, right?
Typically, the rule of thumb is 10% of your drainage area. So you would, because you wouldn't know, but in this case, we don't know the drainage area size yet.
Yeah.
So you can repeat this process a few times if you want. Because if you, like Teresa mentioned, if you set the threshold really low, that means, so the way it's working is, it looks, let's say, so because we're working with the raster data, right? So that means that we have a lot of pixels. Each pixel will have its individual elevation value. So what we are setting is, look at each pixel, and then we provide the area. Let's say, for example, say 100. So from that particular pixel, then it's going to determine, if, how would I put it this way?
Sorry.
You could,
Yes, I had a meeting with the design that I tried to reschedule, but he just started it.
oh,
This one seems to be an interesting one. I mean, I think it makes sense to do iterative, but just that starting number to me, it'd be like, I can think of a square mile, right?
yeah, something like that.
And then I can think of 5 square miles, and said, okay, so from Walmart to Palmer Lane is about 5 miles, okay, so 10 square miles and see what it does. I mean, it seemed like that's the one that will make me think a lot, just that starting number, even though you said just take an engineering guess.
Mhm.
Yeah. So yeah, look at it this way. If you have the threshold little higher,
Mhm.
you will probably pick up the after you run it, it will pick up the mainstream. And then as you start lowering your threshold, start picking up tributary. And then if you really, really make very small the area ratio, then you start seeing little tree branches coming out.
So for example, like here, if we set our threshold higher, then it might pick up, let's say, this area as one basin. But then if we set it lower, we're gonna see that every little
Mhm.
branch here
Will become a sub-basin.
will become a sub-basin. But what we care about is like, let's say like if this was a main crossing, so it's maybe from looking at the LiDAR, this example was pretty obvious, but um
So you can even see the subdivision.
yeah. So like let's say my focus was this is my outlet. I can kind of see from here that this entire
Mhm.
area is coming this way. So maybe I can use that as like my starting estimate, and then iterate from there. Does that kind of help?
And there's no draw area tool on this one, like where you could just draw a polygon and so what's the area of that polygon?
Um, Not that I'm aware of.
I don't think in HMS you'll be able to draw,
Yeah.
because it doesn't have the GIS capability. But if you are able to, oh, maybe, yeah, if you are able to start your estimation process, let's say in other software package, then you can, yeah, predetermine, the estimated area,
Mhm.
and you can set your threshold that way, or so run a few times, then we'll still be able to. It doesn't mean that you have a lot of little area, you will miss the big one. Right? It's just you will still see the big one, but we don't then, have a lot of little ones. Then you can still later on you can still merge all the little ones. It will still give you the size or the shape of the drainage area that we are expecting.
Mhm.
Yeah. Okay, so I would say this one's pretty fine. So you can see everything, even the local streets, right?
Mhm.
Even within the neighborhood, ditches, everything's is being picked up. So this is a pretty fine resolution.
So I guess one other question I have for you is when we first used to do aerial flights to get the Z elevations, we would also send people out
Hmm.
upstream, pick up however many sections we needed in HEC-RAD to physically shoot the bank.
Yes,
And part of that, I think, was because depending on where we did the flight, there might be vegetation.
yes.
So in this LiDAR data, is it picking up? I mean, I have to assume that it's getting the ground and not picking up the vegetation.
So yes, so there are there are two types of terrain data set. So first one is called uh, DEM, and then the second one is called DTM. So the DTM is DEM is the ground. So when they're doing the processing, after they do the flyover, and then they collect all the raw signals, the reflectivity, or the rebound signal. So like you mentioned, if there's a tree, the tree's gonna bounce the signal back first, right? So when they're doing the processing of the raw LiDAR data set, they have a certain algorithm that will read for the tree. So when you get the DEM, which stands for digital elevation model, when you get the DEM, they already pre-processed it. So with that one, all the surface, all the trees and everything have been removed so that you can use. But sometimes for some other uses, people would prefer to have the canopy, they want to see the canopy and everything, then you will get the digital terrain, DTM. So that would be, the trees and everything will still be within the data.
Sure.
So in this case, this is this is a DEM.
Okay.
So everything is being removed. So you can see the houses. The houses is right there. It's above the terrain. So in this case, it's still preserved, but the trees and everything's being removed.
Okay.
Yeah.
So no wrong elevations, but really,
The only thing but for our purposes is even in the channel, uh, whether it has water or not in the channel, it's still likely the lowest part in your watershed. So, it wouldn't affect our delineation process. But going back to what you brought, with the survey, shoot the channel, right? So that's very crucial when you're doing, let's say, hydraulic modeling at less, because LiDAR, if the water is too deep, you will see the LiDAR won't be able to penetrate. So you will see a channel like this because it stops at the water. In that case, then we will use the survey information for the channel crossing. So we will go in and adjust the channel profile, sectional profile. But that's a different, totally
okay,
different topic.
yeah, I don't want to sidetrack.
Yeah, but that's a very valid point. It's something that we do all the time too.
Yeah.
We have LiDAR, but we still need survey. Yeah.
I worked on a Lady Bird Lake project recently, well, a few years ago, and we all had to order a bathyc survey, a BATH survey,
Mm-hmm.
where it was under Lady Bird Lake
Mm-hmm.
to get the bottom of the lake.
True. Yeah.
Yeah, even though nowadays, there's let's say LiDAR, they have like they can penetrate water, but up to a certain depth, then you're not gonna get any rebounding signal.
Yeah. Okay.
Right? Yeah. Okay.
Are we caught up to this point?
So do we put a number in for the
Oh.
area?
Yes, let me go back to mine. So we go to GIS, identify streams, and then we get that pop-up. I'm gonna estimate 0.1 for now. We'll see what it gives us. We'll press OK. And so now you'll see that this orange line popped up. And let me turn off the other map layers so we can see it better. So you can see how it identified a stream that would take in at least 0.1 square miles area of the watershed, size watershed. So it does follow that low point pretty similarly, except when it gets to this point, it almost treats it looks like it's treating it as like a tributary here, this white line. For the most part, you can tell that it was able to identify that stream, right? And so this is like the crossing area where it would cross the road. This might be a bridge section. That's why there's no more road here. And there's a crossing here. Well, actually, it looks like it's actually here. But we can adjust it. So then once we have identified our mainstream, we want to go back to the GIS drop-down menu, go to Breakpoints Manager, and this is what's gonna identify your outlet. So we're gonna go to, sorry, not import. Let's say if you have a shapefile that has those identified points already, but we don't have one. So instead, what we're gonna do is come here to this red dot here, the breakpoint creation tool. And now you'll see that in the graphics menu here, now your cursor is like a crossbow here. And we're going to zoom in into the identified stream, and we're going to place it where our outlet should be. So here we can tell that it looks like the stream is crossing the road, something like this, but the program wasn't able to identify the stream going this way. Because it's not perfect sometimes, it's not perfect. But whenever we set this breakpoint, it has to be on top of an identified stream. So I'm gonna pick the closest point that is still along that route, um, near the outlet. So here where it intersects, I'm gonna choose this section. Zoom in really well, make sure that I'm on top of it, and then just click on it. And I'm gonna name that outfall. Call it outfall 1. And then I create it. And so now it created that point here. Um, if it's not touching the stream, you will get an error message that tells you that it has to be touching it, and then you can go back and adjust it. And so now we're going to click back into the arrow tool here to get out of that breakpoint placement tool. And so now we have the identified stream, our outlet, and we're going to go back to the GIS drop-down menu, and we're going to press delineate elements. And now this is what's finally going to actually break that watershed and delineate it for us using all the information that it already created. So we're going to name our subbasin prefix. We can use, let's say, name it for. Insert junctions. We don't want to do that for this point because our goal is to create separate basins, but we're not really looking to interconnect them. Okay. So then we just press delineate and we let it run.
So it creates the model into the HMS now.
Mhm.
Cool.
And so if we look at it, because maybe if I would have made my area a little bit bigger, it would have just it wouldn't have broken it so much. But for the most part, if you look at it, it's pretty accurate. Um, it's following the high points. I'm sure that if my LiDAR would have been bigger, maybe it would have captured a little bit more, maybe. But we can see that it's following these high points. And generally here, this LiDAR, this part of the LiDAR probably gets a little bit higher. So maybe this would have been a little bit more extended, but our LiDAR doesn't extend that far. But we can see that the high point here, water from this high point would come down this way, converge here. And then because there's a road here, it was able to pick up that road as a high point and kind of use it as a boundary. Maybe there's a ditch here that really carries everything down this way. Here as well, everything's kind of coming down like this. This. Same thing here. It looks like there's some sort of stream here maybe that brings everything through. And it's not perfect, maybe, but it's still a good start off, a good basis foundation instead of you having to go through and delineate these things manually. And you can go in and modify it and define it a little bit better. Another thing for good practice is that sometimes reviewers, whenever they see that your drainage area has this many squiggly lines, it's kind of obvious that you used a program to delineate. So it's nice to kind of go through and clean these up just to make sure that you're actually checking what the program is outputting, because you still want to use your engineering judgment to make sure that what it's doing makes sense.
So I have a question on this. So the goal was to have this delineate our areas for us. That's really what the goal was, and we got that now.
Correct.
But what gets me stuck is when you said identify streams, right? That's where I'm a little off because you entered a number, right? And we got a line, but it did not go all the way to, but it doesn't seem like it was important. So I guess what I'm getting at is when we did this line, you made a comment about this white line, I think. And then it didn't identify the stream exactly. Is there something here?
Mhm.
And there's something like this,
Mhm.
but we stopped here. And we didn't do the second or third duration, and I'm not sure, is that not important to capture all the way to here? When you said identify stream, or was it more for visualization? I guess that's what I'm getting stuck at, because I was thinking, I can see the stream right here, and it looks like it does kind of that. So, but we didn't, I don't think that we didn't look more into that. So I'm just kind of curious what the idea behind it was.
Yeah, I think um
Or was it just to show us how to delineate the area, but we would, if this was one of our projects, your project, you would.
I think that what HMS is doing is there. So in HMS, there are a lot of steps are now hidden. If you because this tool is added into HMS recently or the past, I would say, couple of years. But the methodology is still the same as like maybe 10 years ago when RGI's first included this tool set. It's called ArcHydro. So in ArcHydro there are a lot of steps. But now in HMS, some of the steps were now not, we can't see it. But they're carrying out all these steps in the background now. So essentially, if you remember, when we did our first or second step, we see a lot of little ones, little bits, and that's because we already pick up all these little tributary, all these little ditches and everything. So it's already being calculated. What's showing is really like, you see, all these are identified. So the model knows where, if you drop the water here, the water will follow this one and get to your mainstream.
So it knows on this one up here.
Yes.
It knows that up here,
Yeah.
past this line.
Yes.
It knows.
So this is a kind of like, really like the end illustration, for illustration purposes.
Okay, that's what it's doing, but it's doing something in the background.
Yeah. See, all these, if you see here, it's all real. These are like derived from your LiDAR data set, your terrain.
And that's why that drainage area that was outside of this channel, over here.
Yeah.
Okay, so it's illustration.
Yeah, because that what you're seeing here, this blue line, so this is really what you're seeing here. This is the element, the HMS element. So it's a simplified. So right now we only have 1, 2, 3, 4, right? 4 basin elements. So Teresa, if you can turn off everything now, just leave the HMS element. Flow direction, terrain, you can turn it off. Yeah. Okay. Then just keep also turn off that one, flow accumulation. Then just keep the sub-basin.
Oh, I get it. It's just a visual.
Yes. So you see now this is you can turn on the 2D connection.
Okay.
And then the reaches. Yeah. So now you see that this is so HMS is using your underlying terrain to create the watershed boundary for you.
Mhm.
And each watershed now is represented by a basin element.
Gotcha.
So you got 1, 2, 3, 4 drainage areas. And all these drainage areas, because this watershed will all drain to this outfall, right? So HMS automatically create a outfall node for you here, so that all these basin will drain to the same outfall. Okay, and there's also DA5, this little one here. And then also, as we mentioned, so this element, this is a reach element because because the basin from the top, that's DA2, right? I think that one cannot DA1 and then 2. DA1 and 2, they don't drain directly through the outfall, right? So they have to go through. This is DA4. Yeah, they have to go through DA4 because there's a channel here into your outfall. So there's, remember, we were talking about this concept, right? The hydrologic routing, because the flow from there, flow from here, they're generated at this point. From here to here, there will be some attenuation, right? Your peak flow will drop because you're traveling through this channel. So there's a hydrologic routing happening here. That's why we see these blue lines that represent that reach routing phenomenon. Okay. And then DA4 and DA3, these two bases and 5, they are draining directly to the outfall. Okay. So that's the how would you call it, the schematic, your model layout, HMS model layout that is derived from your underlying terrain.
Okay.
Yeah.
So that makes sense to me now.
Mhm.
Now that I'm gonna go back to what got me stuck is when she did identify streams and put 0.1, I think it was. What would have happened if we put 0.5 in it? What would that have just changed the schematic? Because the underlying terrain data is the same.
It's the same, yeah.
So what would happen? Because we talked about iterations. We don't want to pick up all those little bitty things.
Mhm.
We want to find the big stream, but we put 0.1 in. What if I was I say I need to get the entire channel
Mhm.
and put 0.4 in. What am I doing? Am I doing something wrong or am I overthinking it?
You mean 0.4? You mean if you have
Under identify stream right there.
Yeah.
oh, you mean the area?
Yeah,
Yeah,
she put
okay.
0.1 square miles.
Okay, so
What would happen if I change it from 0.1 to 0.5? How do I know when to stop?
These would be, so these basin areas would be bigger. They wouldn't be this broken down. And I guess essentially, if you put in an area bigger than the LiDAR file, then at that point,
I would
it would,
What the drainage areas being shown are just on the
Yeah.
on the schematic view only, or is it actually changing our results at the outfall? If I change from 0.1 square miles to 0.5 square miles or 0.3 square miles, when I was identifying streams at that step.
okay. I think I would say, so the purpose of identifying to set the threshold is for um determining your stream. So let me think, how do I say this in a simple way to so everybody can understand. So okay, so if I remember correctly, So the threshold, let's say 0.1, that means that you're looking at any particular pixel. So if this pixel has the area 0.1 that is draining to that pixel, then the program will assign that particular pixel as a stream pixel. So let's say if now we are so let's say this is the pixel, right? So we say, okay, so we want if we have a very small area. So let's say this pixel, we only have 1, 2, 3, 4 square draining to this pixel. So if we set that threshold to be four squares, then this pixel becomes a stream pixel. So, but if we say we want this pixel, so if we only have 4 pixels draining to here, but our threshold we set it as 9. So this pixel won't be assigned as a stream because it only has 4 draining to this one, but we set it as 9, so it doesn't meet that criteria. So this picture, therefore, is not considered a stream pixel. So that's the difference. So I would say by changing the number, maybe the outside the shape can change it a little bit slightly because then because the threshold, I would say the outline of your basin may vary a little bit because now we are considering, maybe all the points near the basin because of the threshold. So the cells that are draining to that cell could change, right? So then so the drainage break probably will vary a little bit, but what is internal, I don't think it will make any difference because everything, if it's determined draining to one outfall, that means they are all hydraulically connected. So I would say we can do an experiment, but I do think it's only thing that's going to change. It will be just the outline of the basin. It will change a little bit, but it won't be too much. And anyway, usually what we get from here, we still need to manually smooth it out, like Teresa mentioned.
Okay.
So we don't want to see really like a zigzagging along your drainage boundary.
Yeah.
So and also for this part, this is not going to be the final because we know that Teresa, if you turn on the terrain, so we know that the outfall should be here, right, or here. So this is our initial run, right? So we cannot just take whatever that the model giving us as the final. So we still need to do a lot of verification and make sure, okay, so now our outflow, it should be here. This is just our initial run. So we might need to bring in or revise the drainage boundary to be coming down like this, right? And over here, we'll probably need to we'll probably need to include these from here down, like here. So there's still a lot of manual modification that's required to reach the final product. And sometimes, because remember, everything is derived from the terrain. So the reason that, our initial run, the terrain, the stream was defined this way, right? Because the terrain didn't have a low spot here. So if I were to do this, before we run this, I will probably do a terrain modification, then I will probably punch through right here. So that way, when we run it, the model know, oh, this is a low point. So when we run it, the red line here will come through here. But because the terrain, we didn't fix anything here. So when the model runs it, it sees that, okay, there's opening here. So it will take us that way. And then also, after we run an initial run, sometimes we also need to check maybe there's some streets that would alter your drainage pattern. But because the terrain didn't reflect that correctly, maybe street that has a culvert underneath and stuff like that, like this case. So we will have to, look through the entire model, entire watershed boundary to make sure that, yeah, this is supposed to be draining towards your outfall, or maybe this part it shouldn't be. So we still need to make some modification after this digitization process. Does that make sense, right?
It does, thank you.
Yeah.
I didn't,
Yeah.
You mentioned modifying the terrain. Is that something you do in here or in the shape file?
It will be in GIS.
Oh.
Yeah, yeah. So, because I would say you see all the GIS capability that's um added to HMS or added to HEC-RS. It's just the very basic, I would say, GIS tool, GIS suite that only contains really the minimum functions. So if you still need to do like detailed spatial analysis or pre-processing, like what we're talking about, like terrain modification, things like that, then you still need to use GIS packages. Could be ArcGIS or can be QGIS. That all the detail work should still be performed in the proper GIS software package. Good.
Yep.
All right.
Thank you.
Okay.
Okay.
So, and so from here, so now I developed our basins, and now you can continue with the steps that we did yesterday. Depending on what your goal is, right? Is how you're gonna alter this, because here it connected the watershed, but I'm assuming that based off like the projects that you guys mentioned you guys worked on, what's more important is the peak flow for the drainage area developed. So you have, these extra components that were created, but but if you don't need them, you can delete them. So in the basin model manager, you can just right click and delete, and you'll see those connections go away. And so now you're not considering that hydrologic routing, because the goal is to get a peak flow for these watersheds separately. If that makes sense. And so like this one, you can delete our sink and delete. And so now it looks like the model that we had yesterday, where we just had one basin, and each basin we can come through, apply its loss information, its transformation information, and then run it to be able to develop the hydrograph. But do remember that what we're still missing here are the other components before being able to run. So the meteorological model, 10-year, let's say. And then what's the third component that we're missing? Um,
Control specifications.
Yes. So components, control specifications, new control one. And so this is where we set those dates. And then how do we create a simulation run?
We have to put in the like meteorological data, control specification data, and then go put a little simulation run manager.
Yes. So simulation run manager, new, say 10 year. We're going to use the pressure creep model. And so remember how yesterday we showed you guys that parameter table where you can change the parameters for all the basins all at once? If we go to that area, so the parameter drop down menu, let's say our loss, SES curve number, you'll see that there's a row for each basin here, and you can fill this in here for all of them. They shouldn't all be the same. We can change it up here just to see it through. Say I'll keep it consistent for this. Ah. And remember, these are parameters that you calculate um, outside of HMS. Um, and then we can hit apply. And we can close. And so now we go to each subbasin and we go to its loss tab. You'll see that information filled out. And we can do the same thing for the transformation. So we go back to parameters, transform, SCS unit hydrograph. Here. Oh, so it's only showing me one because I only have one selected. So you want to make sure that you're selecting Brushy Creek and then go to parameters, transform, SES, and now you'll see all 5. Okay. So let's say 15-minute lag time. And these values will vary, will be different for each basin. For now, I'm just using this as an example. So apply, close, and same thing here. We go back to the subbasin, and we go to the transform tab. You'll see that information filled out. And so that should be ready for our meteorological model. We need to set up our rainfall data here. So because we're using that rainfall depth, we're going to use our frequency storm. And here we set up our settings based off the manual that we looked at yesterday for Williamson County. And I'm gonna find some rainfall values so we can input. Mm. So this is Brushy Creek. I'm gonna stay around this area and drop my cursor. I make sure I'm in precipitation depth here, and then I'll pull my values from here. So
Yesterday we used the table, right? From subdivision
yesterday,
regulation,
um,
or is that a different?
I think yesterday we used the Atlas 14. Um, but if the local one has theirs would trump Atlas 14.
Oh,
Yeah. So how Ted said you would start looking at a county level, and then if you're working like in a specific city, then you would look at their criteria. But if they don't have one, then you can always reference to Atlas 14. If it's text out, then they have their IDF curves. So then if we go here, 769. 1.23. 53. 5. 2.84. 3.62. 4.11. And I think 4.94. 5.69. And 6.46. So that's our rainfall data. And there's one more step that we need to do in the meteorological model. Do you guys remember what it is?
set the times, right?
So set the times, but that's in the control. So it's the one I said I always forget.
Oh, right, like click file for the basic.
Yes. Yeah, so you come back to the 10-year and then the basins tab and you assign it to yes. So if I forget, hopefully you guys won't forget. And then for our control, we set our start date. Gonna use January 1st, 2025. 00. I'm gonna do 24 hours. So I'm gonna do 02, January 2025. 00. And 1 minute.
What is the start time and end time doing? Because I can see we don't have no time in there. What would that have actually been like 8 a.m. to 3 p.m. the next day or something like that? I mean,
So
is it using it for anything other than the output header, maybe? The start time and end time?
So it's telling you when we look at the hydrograph, you know how it has a time on the x-axis? It's basically telling you that storm duration like for that hydrograph.
Okay.
And then the interval is telling it how often it's gonna compute to generate a flow for the hydrograph.
Yeah.
And so by putting 00, we're basically saying midnight to midnight in a way.
Yeah. Or sometimes you can also do, another way to do it would be, let's say if you could keep the same date, instead of, let's say, January 1 to 0 to January 2nd, you can also do January 1, 0 to January 1st, 2400.
Okay.
Yeah. So it's essentially the same thing.
Okay, I got it.
It is how you specify your, 24 hours.
So now we have that, and we can go to the compute simulation run manager. Oh, sorry. No, yeah, simulation run manager. We have our 10-year already. We already made it. So we go to the compute menu, compute tab here,
We did not show up.
or
Simulation one manager.
Did you create?
yeah, did you create one?
Select your basin file, your
Oh, okay, yeah.
Do you have yours?
think I do, but I got sidetracked when I was supposed to enter my loss information. Their parameters.
Yes, under parameters. And
Okay,
then,
so do I need to go back to something to parameters?
so you do have to go back to your components tab
Okay,
and select Brushy Creek so that you'll see all 5 subbasins. And now you can go to parameters,
okay, loss,
loss,
so loss, I see per number.
remember. And this is where you fill out, and I can open it. Mm. These will vary, just to emphasize that for each watershed.
Can you actually do like copy and paste with your mouse when you're working in this software?
yes. You can, if anything that you see here, for the table, you can manipulate your data in Excel and then you can copy back in here.
Mhm.
Okay, so I did that.
So,
So that was for my,
mhm. I'm gonna apply, and then you can close out.
parameters, and then I have transform.
Mhm.
And
Hi. 15. And I think this should maybe help with like those crossing analysis that you guys said you guys were working on.
Like Colin was mentioning, the roadway with one bridge crossing, right? That, so this example will be very relevant. Short roadway section with one crossing structure,
Mhm.
then you can use this approach to drainage that stream by crossing.
Mhm. So,
so we got the simulation run.
so now we have everything. We have the simulation run, and now we should be able to run it. You can run it by right-clicking on top of the 10-year name and pressing compute, or you can come down to the drop-down menu here that we saw yesterday and also compute. I'll just do it. Everything worked out. So now if I go to my results, I'll see my global summary. So remember how yesterday we only had one row here because we only had one subbasin, but now we have multiple subbasins. Um, and they each have a different peak discharge because even though we use the same transformation parameters and same loss parameters, they have different, it's using a different, um, like drainage area size. And it's analyzing each watershed basin individually of how it's going to react. So now we can come here, look at our graphs, our hydrographs, our hydrographs. What was the red shape? Do you guys remember? Or
The loss.
the loss? Yes. And then our blue was precipitation. But yeah. Do you guys have any questions?
Yeah, that's cool.
So I had one warning, and I'm trying to figure out what it means. Control specification time interval is less than duration of macro. Precipitation data will be interpolated. So if I go down to,
Did you use 1 minute?
I think so.
What was your range?
Yeah, let me see. Going through my mobile. So I go to frequency storm. Is that where I go to?
Yes.
And we use them all. So I don't know. I mean,
769.
769, 123, 153, 215, 284, 362, 411, 494, 569. Yeah, 646. Intensity duration, 5 minutes. Storm duration, yeah.
Okay, so we all have
Or
that.
for all surfaces. You got
So we could increase the time interval. That it's using to calculate the program. So let's say we increase this to 6 minutes. So now it's telling me to reduce. So let's say 5 minutes. And so now it's okay. And I think the threshold for Williamson County was 1 minute minimum preferred and 6 minute max.
Yeah, I think that's for subdivisions.
For subdivisions, yes.
So, okay, so intensity duration, 5 minutes. That's not what you changed, is it? And you changed to 6 minutes? Is that what you changed?
I changed it from 6 minutes to 5 minutes.
Well, it's still not narrow.
Show me where we look at
And the control
Control
specs
control specs. Okay, that's where I have it. 1 minute to 6 minutes.
to 5.
No, I got much other things.
I think are those the old messages?
Okay, so you do 4 minutes, it says the interval is less than. If I do 5 minutes, it says reduce it.
Oh, 15 minutes.
Yeah.
Yeah. That should be what.
So I'm trying to understand what this time interval. I take a step back to our earlier stuff. Our time interval is telling us what? Is it telling us that the peak flow,
So
the assumption is that the whole entire draining basin is already developing, providing some maximum Q. And we're just analyzing this for 2 minutes.
So the time interval that we're inputting in the control specs is telling the program how often it'll calculate this direct flow. So you see how here, if I go to my control, I have it set to 15 minutes, right? And if I go to my results here, and if I go to the hydrograph, go to the time series of the hydrograph. You'll see here that it's calculating the direct flow at every 15 minutes.
The runoff
The runoff
from
direct.
the basin.
Correct.
That makes no sense to me right now. So why would we have 1 minute on there?
So that 1 minute will be, yeah,
Why would we have 1 minute?
Like why we had it initially? Or
Well,
why
yeah,
would the county specify 1 minute
yeah, for subdivision.
for subdivision?
For subdivision. Yeah, from
so we're talking runoff right now, not total Q.
Yeah.
And it's accumulating with the hydro. Okay, I'm trying to put all this together.
Yeah. So why would, let me think, why would subdivision they want to use one? Because usually I can see the reason. Because let's say if you run, okay, I kind of know. So let's say we're using every 15 minutes. Sometimes people use 10. That's because you would think that your hydrograph, is probably pretty like smooth curve. So if you're reporting every 15 minutes, you probably won't miss anything in between, right? So if you run every minute, that means your output is every single minute.
Oh, it's more conservative.
So that they're trying to see, they're very conservative so that they don't want to miss if there's any.
I got you.
Yeah,
I got you.
yeah,
All right.
but I wouldn't, typically, for hydrologic response, it's not going to be so, what's the word? Instantaneous, right?
instantaneous change.
That it's not, water is going to be slowly, the flow that goes down, it shouldn't be like this. Within 1 minute, your flow will be jumping from here, let's say 50 CFS to 70 CFS. That doesn't happen within 1 minute. So hydrologic process is a very slow
That
process.
makes sense. All right, yeah, a lot of our deal, we see houses just being crammed into very small lots now.
Mhm.
And so there's not a lot of green space.
Yeah.
There might be a park, but I can see what you're saying. You're dealing with people and their expensive homes and they want to make sure that they see.
They capture everything.
Yeah, okay.
Or it could be, I don't know the criteria, maybe the criteria they're leaning towards to like a very short duration storm or very high intensity storm. So that way, they're not analyzing, use the 24-hour storm event. Maybe that's my
Oh, I see.
my guess.
It's different than what you're working on.
Because a roadway, usually this is a bigger infrastructure. You will go with 24. For the, I know that for some like urbanized area, they start looking for like maybe 6 hour duration, or even 3. So they're looking for this short duration, like high intensity event. In that case, I would think, yeah, if the event itself is so short, then if you only showing every 15 minutes or 30 minutes, then you don't even have that many data points, right?
Mhm.
So that's probably the reason they reduced to they wanted to see every 1 minute. So that they don't miss any, any information. Okay. Yeah.
Telling our owner. Be good to talk to about that.
Okay. So do we have any questions about using HMS to delineate or any step? I don't know.
And I'm sure there's a lot more to this topic. Once we get to, like an actual project, then when you're working on it, then there will be a lot of your judgment that you have to implement to your a lot of decisions to be made, how you want to, do your drainage area and in modification, uh, things like that. So that you are carrying out the project.
So without GIS, it's not possible to move that outfall down, right?
So this is a I don't think in HMS you can do any editing, so I would still consider using a QGIS the meantime, or the GIS department uh, has the availability to uh, I don't think they would do it for to accommodate everybody's request. So better that they can maybe give you a license.
Yeah.
You do whatever you want. I think that's the best. But for the meantime, I would think what the GIS provide is the Italian model. Let's say you know your area of interest, then you can pass that along to the GIS group, say, in the county. You already have this information. You can clip this area for us, and I'm pretty sure they'll be more than happy to hand out.
It's on our website. We send it under GIS Hub. You can request, and it tells you who to contact, and they'll set the LiDAR. That answered my own question on that. It's where you got Brushy Creek from somebody, and I didn't know where you got it from, unless it was from
We got it.
Clearinghouse.
We do it ourselves.
Yeah.
Yeah.
But I mean, we started off from somewhere.
Yeah. So the LiDAR nationwide, there's a lot of I would say it's a research effort. So there are different data sources that provide LiDAR information. So there's a different level. So national, there's a different data depository that you can get national data. And then in Texas, there's one that's called TextGeo. Let me see. So we can share the information. So what that the service is providing. This is a free. It's kind of like a portal that you can get a lot of information from this service, and they collect information even from USGS, everything. They put it together so for Texas user, we can use it. So you can grab information like LiDAR data from here, or you can get different aerial imagery. Let's say you want different background, aerial, you can also get it from here. And then also, if you're in the coastal zone, you can also get the bathymetry data from here as well. So this is a good data hub for us to obtain. Okay, but the thing is, let's say the LiDAR data you download from here will be like files. So you have to download like a batch data set that will contain so many tiles. Then you still need to pre-process it. You have to mosaic all the tiles together to come up with a complete set. So what usually what county the GIS department, what they do would be they would, I'm pretty sure they probably get it from here too. They will get all the tiles, they will, so what you're seeing on the county website, that final product, they probably took it from here, then already mosaic everything together, and then they were providing that to the citizen as a final product. But for internally, I'm sure that's already available. So, and it's probably like a county-wide. So it's a very big. So if you ask them, well, could you send it to us? They send it to you, it will be really big. But if you, like I said, if you tell the GIS group, now we have this area of interest, can you just clip this area so we can use for our project? You can probably send it to you like hour, the most 2 hours.
Okay.
So that would be.
Yeah, we have
Yeah.
a file that has all of the tiles and stuff,
Mhm.
and I use it in OpenRoads, but I guess it's also.
Yeah. Yeah, so I would, the way I see, it's probably best for them to get your license or increase the license so you guys can do your own thing. That would be really, I'll say that's the best. And I'm pretty sure the county, for them to add a license, it's not that much. If they say no, then I don't know. So if they say no, then you just go
QGIS.
GIS. Then they can give you the full LiDAR set and you can click as you wish. Yeah. I think that's, in the meantime, while you get, while you're getting through, all these application, approval process, the meantime, you can, yeah, use it, so.
Because you can, I was testing it this morning and because you can't do your land use here, right? In HMS. I mean,
Yeah.
you can, but you need more pre-processing with GIS, which you guys don't have. So, you can export this shape as a shape file to import it into, I'm assuming you're doing the land use in ORD right now, or
Yeah, literally just like sketching out.
shapes.
Yeah.
And then you're not doing ORDDU, right, to like calculate it, or
Not to calculate it, no. We just use that for
like for drawing
like
purposes.
searching about like when you have like on the top left the drop down, like either modeling or like drainage and utilities. I just use that for putting in the actual culverts and stuff. Like not really modeling.
Okay. So then for the land use, how are you getting the weighted, I guess? Like what's your process for that?
I've only done it once because usually it's just like farmland. Only had this project that really had to get broken up. But yeah, it was literally just me sketching around the suburb and being like, that's the acreage, and then applying the.
So doing the calculation outside of ORD,
Yeah.
but drawing, I guess, to get the area
Using
in.
it literally just as a sketch. That's what they
I see it. Okay. Okay.
be nice to have something,
Yes.
but maybe I'll have to come back for a GIS training.
Yeah, if you guys get GIS, we could. You would never want to go back. I don't want to go. But we can still run through EU and how to do the hydrology so that you can get the calcs from there. We can do that. Um, but like I said, if you get curious, you can export these shapes. If you go here to the GIS drop-down menu, export layers, and you can select the layer type that you want to export. I want to export the subbasins. I just press next, and it's going to save it as a shape file. And you just pick the folder where you want it to save. And it'll save it there. And the way you bring it into ORD is that you just attach it as a reference, like a normal DGN reference, and it'll bring up the shape. You may have to apply the scale factor, but it should show up. If it doesn't, what you can do is that sometimes, even though it's a shapefile, ORD brings doesn't ORD reads it as an empty shapefile, so it doesn't bring it in. Sometimes it's glitchy like that. But what you can do is if you know that the shapefile has data, like it has a shape, you can bring it into QGIS as a layer and then just re-export it again as a shapefile and then bring it into ORD and it should show up. Sometimes it's glitchy like that.
Yeah.
But that's not hard to do if you do QGIS is free and adding a layer is very, very easy and then saving it too.
And if you QGIS, they might as well just do this processing.
In there, yeah, yes.
So you don't have to really like.
Bring it into ORD at that point. But okay.
Okay.
I think that's what we have for HMS.
And want to take a short break,
Mm-hmm.
then we can come back.
Yes.
There's still some donuts in our break room. Do you guys want one? And just
I'll take some water.
water? Water come from? Where?
If you
I might ask Kelly.